Can you guys hear me? Yeah. Perfect. All right. My name is Brian Sucker. First time presenting at a conference, so give me as I might mess up. Probably not though. As he said, I'm going to be giving a speech on building a secure environment for operations. Docker is a big thing now, so it's mainly based off of DevOps, people like Docker, so how do you build a secure environment for your operations that are using Docker. Who am I? Husband, father. Currently, I work at, I'm a senior cybersecurity architect at Dragos. It's an ICS company. Not going to be talking about them because this talk is about DevOps and building orchestration. So I'm going to get that out there to begin with. Previously before that, I was a lead security engineer. Did a whole bunch of different things with the government. 10 plus years of experience. Also, one of my passions I like to do is tinker around at home for home automation, security cameras, Z-Wave, all that sort of stuff. Kind of a hacker at home. So what I'm going to go through is first containers, what they are and why you care. Configuration management, what it is, and again, why do you care? And then talk a little bit about security, both host-based security and container security. And then at the very end, I'm going to pull it all together, talk about how to do containers, configuration management, and security all at once, which is ultimately the end point, the end goal. And feel free to stop me anytime if you have a question. At the very end, I'll be doing a demo when I close it all together and going over more stuff in code as well as asking questions. So, kind of gave it away, but quick question. Who here is familiar with containers and Docker and uses it? All right. Who doesn't know what Docker is? What do you think Docker is? If you had to guess.
Kind of secure environment.
All right. So, Docker is the main software company that actually is doing containers. It's the most popular one. Containers is not necessarily a new technology. It's been around for a while. Some people that use layers, might know containers. Some other methods of containers, Red Hat, they do OpenShift and stuff like that. Docker is the main popular one that a lot of people use. Again, it's a technology that allows applications, whether it's your web, databases, home-built apps, whatever it can be, you can abstract it out and run in isolation, so to speak. It's not the same thing as a virtual machine. Some people that aren't as familiar with what containers are, sometimes might relate it to. They're totally different. They have similarities in the fact that they do run some apps and stuff like that. The biggest thing, and I'll get into it as we go further along, especially on the security side, containers is a minimalized aspect of it, whereas a virtual machine runs an entire stack within the OS. Again, Docker is the most common container service. Started big in 2013. So a few years now, and that's kind of why it's been really prevalent in a lot of things. Also, just recently, which is kind of added to the success of Docker, Microsoft is supporting it. So you never thought that you could see Microsoft supporting a lot of Linux, something that might be more Linux-based. And so I thought that's kind of interesting. Again, this is a similar abstract of what containers can do for an environment. As you can see here, you have multiple different apps that you can run, all within on the Docker layer itself. Of course, down here is your traditional OS. Think of that as a VM. It doesn't have to be a VM. As you can see over here, you can do the same thing as a VM, or over here is an actual your own infrastructure. It still applies the same methodology. One of the biggest things that really helps out is you can run Ubuntu containers that are built based off of Ubuntu on like a CentOS system, or containers that are built off of CentOS on an Ubuntu system. It allows that transparency to work. Really what that helps out is it puts the developer in the DevOps aspect. Developers can build containers no matter what it is, they build it, it works, they can test it out, and push it into production. And for the most part, they're guaranteed to work. It's an immutable object. I won't get into too much into details on that. That's another time. But if you want to, you can look it up. But here, as far as the DevOps process, you're developing, you're testing it, the CI/CD, going over to your staging, and then on to production, and you get bugs, goes back into dev. That whole loop and cycle is key and paramount as part of the DevOps process. Being it to be fast and quick helps things out. Docker helps make that happen. A perfect example, bug fixes. You want to be able to, a bug comes in, you want to get it out ASAP. Docker can help facilitate that. Security updates. Oh my God, there's a new, OpenSSL vulnerability. Maybe I'm vulnerable to that. Let me go ahead and patch my container, ship it back out, so that I can fix that patch really quick. That's another thing where Docker helps facilitate that very fast. Sorry, I clicked one too many times. Configuration management. So I talked a little bit about Docker. Now I'm going to talk about configuration management. Configuration management in the top level is just a way to ensure that it's a process that ensures your changes are consistent. It's based off of what you built, what you want for your production or your development environment, whatever it is that you're building. You have a set of requirements, you have a set of what it needs to be configured as, and configuration management is ensuring that's actually built that way. One of the big tools that I use is Puppet. I like Puppet, but Puppet isn't the only one that you can use. This talk, I'll mainly be using Puppet to showcase with examples, but there's other tools out there as well, such as Chef and Ansible. Ansible is a little bit newer now. It's only been a couple years now on the block. Hasn't been around too much, so most people might be more familiar with Chef and Puppet. Puppet's been around for quite a while now. So again, the big thing why I like Puppet is it's a declarative language. It has the client-server paradigm, and it has a REST API if you want to do a whole lot more advanced things. It's a mature framework. There's a lot of contributors to it. There's the Puppet Forge, where you can find a whole bunch of modules that people have contributed to and actually go download them, use them. There's a whole lot of examples out there. So it's pretty user-friendly for someone that is just starting out. Again, how Puppet kind of works, for the most part, you have a Puppet master and a Puppet slave. Your slaves are all the nodes, and when they run the Puppet agent that's running on the system, so that's a caveat, you do have to have an agent on the system. Some people don't like that, so if you're using Puppet, be aware of that. So if you're running an agent on the system, it runs, it goes back to Puppet Master, pulls down its catalog. What is my configuration supposed to look like? What am I supposed to have? So that's defined on the Puppet Master itself. It then goes through and defines all that, whether it's setting up a particular file to have a certain permission, whether it's installing particular applications. Whatever the case may be, it then feeds it back into the Puppet Master saying, hey, this is what I changed and this is what I did. So it's a continuous process, but it helps ensure that you have a set standard, and that standard is repeatable. Because on the Puppet Master, and I'll get into this in the demonstration, you can create a manifest that can be applied to multiple different nodes, which means you only have to do it once and apply the same change across everything. which is very beneficial, especially in a large environment when you start scaling to, tens, hundreds, thousands of hosts, to be able to write it once and use it multiple times. So a little bit about security. So security, a lot of people, this might be review. Some examples of good security concepts when setting up a secure OS. You want to disable unnecessary services. Why have FTP running if you're not using it? It's bad. You shouldn't do it. Also remove unnecessary packages. Apache, even if it's on there and it's not running, probably still a bad thing. You probably shouldn't have it on there. Keeping things as lightweight as possible is, in my opinion, a good practice for security when you're setting up your environment for operations. Even in development, it's a good consideration to do. Setting limits on who has access to what. So again, you don't want every user to have access to every file. That is probably a bad thing. If someone happens to have access that they shouldn't, then things get leaked, or they do bad things. In a production environment, that's definitely not what you want. In a development environment, probably not what you want, so you should probably treat your development environment the same as your production environment if you can. One of the other things is default configurations. SSH is a good example of this. It's a default configuration for a reason. It will work for a majority of people, but all because it's a default configuration does not mean it's a secure configuration. Root should probably not be allowed to log in as SSH. Sometimes by default it can. So going through those default configurations and ensuring they're set to what you want based off of what your configuration dictates is paramount and important. Puppet helps facilitate that. One of the things that I use in Puppet is a framework called SIMP. It's open sourced. As you can see here, you can go to github.com/SIMP. It's a collection of Puppet modules. They're also on the Puppet forge as well. And basically, it's a framework that enables a lot of default compliance and security standards from the get-go. Out of the box, by using SIMP, you can actually, for the most part, be completely, almost 100% compliant with most of NIST 853 revision 4, all the different standards that they recommend you should do. Which, in my opinion, is a good thing. It gets you to a good known starting location. They also include some tools in the SIMP framework, such as OpenSCAP, which is the framework to actually be able to run reports. They have compliancy built in, so you can actually do matching one-to-one from, if you happen to be using HIPAA or you happen to be using, STIG, you can do that one-to-one mapping between what your compliancy dictates and what might be referenced within NIST or whatever standard. So that's why I use it. Gets to a good known location, and you know what you can do from there on. Again, on host security, you should probably be auditing as well. So what are the common things a lot of people like to audit? Package installations, login, authentications. And if I'm using Puppet, I want to know what Puppet changed and if it changed anything whatsoever. If it disabled a service, I want to make sure I disabled the service. Some of the things I use for audit logs is, a lot of people might be familiar with the ELK stack. I use ELK just because I like Grafana a little bit more than Kibana as far as for viewing the logs. One of the big things why I like Grafana is, hopefully no one is in here from Splunk. Or Elastic, yeah, because I don't like it, Kibana. With Grafana, it's open source, which means there's a lot more flexibility. One of the things with Grafana that you can actually do is by default, lock it down to where you can do, user authentication. Sometimes with Kibana, you have to buy the X pack and do some other things. With Grafana, it's open source, you can do it for free. I'm all about free. If it's free, I don't have to pay for it, and I can use it. Also, it's a better business sale for sometimes in companies. What's the bang for the buck? And a lot of people, they ask, well, if I'm going to spend X dollars, why does it really help me in security? You might not see it initially, so selling free is sometimes a little bit easier. So container security. This is kind of where I think Docker is going to be a huge player in the field moving forward. If it already hasn't, a lot of people are getting up to speed with it, and it greatly improves your security posture. It works by doing, security in depth. So not only can you do the host security, but then you can also have Docker security built on top of that. One of the biggest things that it helps with is using kernel features such as C groups and namespaces. I'll talk about those here in a minute, but those are two critical things that helps ensure your Docker containers are running in a semi-isolated state to help ensure that one's not talking to the other, all still on the same host OS. You can also start applying, Linux security mechanisms, whether it's AppArmor, which is by default built into some of the Docker daemon itself, or SE Linux if you happen to be running, on your host OS as well. And there's a lot of great talks out there if you want to do a YouTube for Docker, AppArmor, Docker SE Linux. They'll walk you through actually setting up those for your environment if you choose. All right, so kernel namespace. Why does it matter? Namespace is a really something I started learning about a couple years ago. Also, as I started learning Docker, because I didn't realize the kernel features that were available that Docker was actually using. And once I read about them, I was like, holy cow, why didn't we use this? Why haven't I been using this to begin with? Some of the stuff you use without realizing it, but other times you don't. So Docker utilizes it by, for example, in the mount space, having the ability to actually mount a volume inside your Docker container that it sees, and if your namespace is written in such a way, it won't see the other things surrounding it. Where that comes into play is, for example, the root file system. A lot of times, you don't want everyone looking at root. But there might be certain things that you want to mount, and you might only want to do read-only. For example, if you're running a container that is, just parsing logs, you might want to mount, var log as read-only so it can actually read the logs. The mount space, it helps do that. PID is one of the big ones. It's kind of interesting. So PID, within a container, the application that's running always starts as PID1. It's the first thing that starts up in the Docker container. Well, inside the Docker container, the PID namespace is unique to the host OS. So within the Docker namespace, it actually shows up as 1. External, it might be 1, 2, 3, 4, 5, whatever sequence that it actually started at on the host OS, which helps that separation. I mention it more so that you're actually aware if you're trying to debug and you're on the host OS trying to debug what's going on, and you might have 100 different containers running, trying to understand the difference, and you're inside one container, it shows up as PID1, and it's not the same external. So that's more just for SA. The user space as well is critical because you can allow an application to run as root internal to your container that isn't root on the host OS. So that is a big one. There used to be some people that were scared about, getting, elevated privileges to root in the host OS. In earlier versions of Docker, that actually was a problem. That was actually patched early on in the 1.x cycle. So if you're concerned about that, look it up. You'll see, read people, how it's actually been patched, what the vulnerability was, and why it's not necessarily an issue anymore. So C groups. One of the things I like about C groups is similar to like in VMware or whatever the case may be, you can limit and throttle your actual VMs, the amount of memory and or CPU that they actually end up taking. So control groups allow that within a Docker container. So where it's really useful is, for example, as an operations perspective, you can set control groups on a particular set of containers, mainly like memory. We all know Java sometimes likes to eat up a lot of memory. Well, if you run 100 containers that all eat up 32 gigs of memory, and you only have 32 gigs on your system, that's probably not going to be a good thing. You can set C groups to limit the amount of memory per container, and in essence, kill the containers, when they get to a certain part and restart them. That's a whole separate talk with Java and Java containers in memory, but it's something to be aware of because you can put limits, which is very good. All right, so now putting it all together. Again, like I said, I use Simp, which is a collection of modules with Puppet to initially set up my secure OS. What you see here is a set of code initially within a Puppet. By default, there's the site manifest. The site manifest is kind of your defaults that apply globally across your entire environment. Puppet also has the construct of you can have multiple environments. I won't get into that, but to be aware of, if you can use the same Puppet master for both a production environment and a dev environment based off of how you set it up. As you can see here, the environment I'm in is Simp, which actually happens to be the production environment as well. It's just assembling. But in here, you can actually see the type of compliance profile. Okay, I talked about compliance previously. Well, right now, I'm adhering to the NIST 853 revision 4. What this compliance profile is, you can read the Simp documentation to get better understanding, but it's just a compliance markup, so you can actually see, what is actually hitting if things are failing and stuff. But the scenario itself, that's more important. I'm saying I want Simp, which means I want it compliant and fully secure, which means I want to use all the Simp framework, which from setting something up from the ground up and you're just starting out, that's what I would recommend, and you can start, going from there. Again, this is that same site.pp. You'll see down there at the very bottom some other options that are included. One thing I'll mention with Puppet is Puppet uses Hiera as a database. It allows you to set different variables for different nodes and or environments at a higher level construct, which allows you to reuse that same manifest across multiple different nodes, like I mentioned earlier. So once you actually have your site.pp, you have, again, I'm in the Hiera and individual hosts folder, and you'll see that these are all the ones that I have defined right now, which in this small test environment, which I have running on my laptop, is the 4 host names that I have running, and I'm going to take a look right here at the Puppet site 1. Basically what this shows is it shows the classes that I actually want to include that were not part of the standard site.pp. And as you can see here, I've included quite a few. One of the big ones that I decided to add was TFTP boot, which just allows me to pixie boot, which is how I bootstrapped all my other VMs. R10K is a key thing to mention real quick. If you're using Puppet, I recommend you take a look at R10K. It allows you to actually sync your code directly with a GitHub or any of the Git repository, whether it's an internal-based Git or an external-based Git. So you can actually do that CI/CD for your Puppet manifest and modules as well, and tie it to particular tags and versions. All right, so for Puppet with Docker, how do you do it? Gareth, he came out with the Docker module. It is approved on the Puppet Forge. There's actually a Puppet Docker module that's based off of Gareth's. I use his, as you can see, so do a lot of other people, to actually set up Docker. It facilitates a framework around installing Docker as well as running all your applications. So real quick, in essence of time, I will go through the demonstration because the demonstration is mainly focused on this aspect. All right. Everyone can see that. Okay. So what I'm logging here is I have both my Puppet VM as well as my Docker VM. Within Puppet, you'll see that I'm in the production environment, in the modules, and the site module, which is the one that has everything defined. And you'll notice I have both Docker Production and Docker Nginx. Docker Production, all it basically does is installs Docker and sets up the environment for Docker. Here at the very bottom, you'll notice that I have IP tables rules. That's because IP tables are needed to forward communication between Docker hosts and the actual outside. You can't have two things manage IP tables, and Puppet manages IP tables, so therefore you have to add those in manually. The Docker Nginx is actually what installs my containers themselves. And over here you'll see that I actually don't have any Docker containers running, no Docker images. So over here, I'll go into my hosts, if I can type, edit my Docker host config. You'll see that I have the Docker Nginx commented out. Once I uncomment it, go back over to my Docker host. I'm going to elevate to root just because I'm forcing Puppet to run. But in general, Puppet would run automatically in the background. So it's going to go through. This is what I was talking about earlier. It's talking back to the master saying, hey, what's my configuration? What does it need to be? So I can actually, grab everything down and set it. While it's doing that, I will show you my Firefox browser. And if I can see my mouse. You'll see that I'm trying to get to my Docker VM itself. That's the IP address, but it's not actually coming up. That's because it's just now applying the Docker containers themselves. Again, if I do a Docker ps-a, you'll see that it's up. You'll see that the one I really care about is the first one. That's port 80 translated to port 80. And you'll also see that my IP tables also are allowing port 80 to now communicate, as you can see right here. So if I go back over to here, refresh, now I can actually see Nginx. That was all facilitated by installing the Docker container, the image itself. If I go back over here, you'll see I now have a Docker image that's on there. You'll see down here, I actually don't have any network access, so this was all done in a closed environment, which in some cases is very important. So I did this by sideloading the Docker image using a tarball. So that's kind of it in a nutshell. I know it was kind of really rushed, but let me get through to the very end. Are there any questions real quick? Yes?
I'm not very familiar with Docker, so that might be a really shitty question, but from what I understand of the brief, the bins and libraries that depend on your Docker image are also contained within your Docker. Is that correct?
So the Docker daemon itself runs the images, and so the images themselves are on the local host OS. So
the library is not within the Docker.
Yes, that's what's on the host OS.
Okay.
So, but you pull them down through either the Docker Hub, so you can set up an internal registry, or you can actually, you can, like I said, set up an internal registry which you point your Docker daemon to pull down your images, set it up to an external registry, Whereas I had a Docker image that was tarball that I did a Docker load, essentially forced public to do it, and actually pulled it all down. So
that mitigates the slow dev cycle from whoever maintains that Docker image if they don't update their libraries. Say, for example, I have a security vulnerability.
Yes, so that's where your CI/CD pipeline comes into play. So if your application is based off a different base image, then your base image that then gets updated, forces a rebuild of your container, then gets those container vendors out the door faster. So that's where a lot of people separate your base image from your actual production, like where your code is. You can do multi-stage builds. Any other questions for it? Yes.
Are there any operating systems?
Well, both, yes. You've heard.
Are there any operating systems solely based off of Docker?
There are not solely based off of Docker. I don't think. I know there's been messing around with like VMware and stuff like that to actually use some, and like instead of using VMs, like using containers. Amazon Container as a Service or Azure Container as a Service. Those are sort of like all these containers to spin up, stuff on back and run, but you don't necessarily have to interface with those external host-based systems. So does that kind of answer it? Kind of.
And what's your 853 output look like?
What's the what?
Does it graph your compliant or not compliant with all the controls?
Yeah.
Oh.
What does it look like?
Yeah.
So on the default sim, I would actually direct you to the project documentation. I don't have OpenSCAP pulled up, but you can actually, if you want to use the map, can pull it up and show you what the actual baseline looks like as far as the false positives and all that based off the frameworks. I know we're out of time, but if you see me afterwards, I can answer questions.